So welcome to Lesson 3, Night 3. Tonight we'll look at stellar and planetary evolution. So whether you realize it or not, or whether you caught it or not in the first lesson, last week, or the second lesson really, last week we looked at the Big Bang. Well, the Big Bang theory says that the Big Bang itself only produced hydrogen and helium and possibly some trace elements or some small amounts of lithium. So the question would be, that's great, where do the stars come from? And that's really where we are tonight, stellar and planetary evolution. So we're really picking up the Big Bang where it left off in the fact that all it produced was hydrogen and helium and possibly small amounts of lithium. So again, this is our tonight, lesson 3. Next week, organic or chemical evolution. That's the supposed evolution of life. We'll talk about that. The following week, creation or evolution, macroevolution. That's the supposed changes of kind. So one animal changing to another kind or changing in phylum, changing from one major family of animal to another. And then after that, the next week, we'll wrap it all up with scientific laws that the Big Bang violates. And so I really saved that to the end to walk us all the way through the complete evolutionary story before we wrap it up that way. 3 words we looked at last week. We'll look at them again. Science, cosmology, and evolution. So science, this is from Webster's, knowledge about the natural world that is based on facts, learned through experiments and observation. So obviously you can catch some of the key words there. It's knowledge about facts, learned through experiments and observation. So I'm always going to be asking, so is this science? Does this fit the definition of science? And then cosmology, I'll just give us the leading definition, again from Webster's, a branch of metaphysics. Now metaphysics is a division of philosophy that deals with the nature of the universe. And so indeed this is, by that definition, cosmology. Disclaimer tonight, that's really important tonight as I talk about distances. Tonight I'm going to be using some major distances. I'm going to say this is 10 light years. This is 1,000 light years away. Keep in mind, the goal is not to discuss the accuracy of those ranges. I think we can all agree these stars and galaxies are very far away from us. The idea is to use what evolution, their distances, and analyze their theory. So when I say something's 2,000 light years, it's not so that we can debate, well, is it 2,000 or something less? We'll talk about starlight travel much later. But again, it's comparing what their theory says about these things. So as you think about light year, light travels 186,000 miles per second. Now that's pretty fast, depending on how you measure it, right? Sure, that's fast however you measure. Well, what about if I convert, how far would light go in a year? Because again, we're measuring the distance that light would travel in 1 year. That's a light year. Well, it's about 6 trillion miles. So when I say 1 light year, I'm talking about astronomical distance. And so when I say 1,000 light years, again, you get it. But I want you to get it. That's okay. So again, we're using their ranges to talk about their theory. Fair enough? And we'll talk about distant starlight and starlight travel later. So the Big Bang, again, this is their definition from space.com. The Big Bang theory is the leading explanation about how the universe began. In its simplest form, it says the universe as we know it started with a small singularity, then inflated over the next 13.8 billion years to the cosmos that we know today. Again, space.com goes on to say, because current instruments don't allow astronomers to peer back at the universe's birth, much of what we understand about the Big Bang theory comes from mathematical formulas and models. Now you should catch that already. We're moving away from science, observable science, measurable science, and we're talking about mathematical theories, mathematical models. Last week we looked at cosmic evolution, the Big Bang. This we look at the origin of stars, planets, galaxies. Psalm 19 says, the heavens declare the glory of God, and the firmament shows His handiwork. Day unto day it utters speech, and night unto night it reveals knowledge. There is no speech nor language where their voice is not heard. From anywhere on the earth, typically, if it's a perfect visibility day, you can view anywhere from 2,500 to 3,000 stars up in the night sky. It is absolutely beautiful. Indeed, as we look at this picture, you can see some stars that are white, some stars that are blue, some that are orange. Indeed, you can see a part of the Milky Way, our galaxy in this shot. Indeed, the heavens do declare the glory of God. But can I tell you something? We had no idea. It was in 1990 that we launched the Hubble Space Telescope and put it into a low Earth orbit. And it began to send back images that we could never have imagined. 20 light years from home, this shot, over 3,000 stars. Look at the diversity in the stars. Blue, red, yellow, small, large. It was amazing. M57, 2,300 light years from home. Polar ring, look at that. Absolutely beautiful. This is M16. This is the Eagle Nebula. 6,500 light years from home. This is M82, also known as the Cigar Galaxy. 12 million light years from home. This is M94. This is another galaxy like ours. This is a whirlpool galaxy. Look at all the stars in the outer band. Absolutely incredible. 16 million light years from home. The heavens indeed do declare the glory of God. This is the Pinwheel Galaxy, M101, 21 million light years from home. This is Sombrero Galaxy, M104, 28 million light years from home. This is M51. This is another Whirlpool Galaxy. This is a different galaxy right here. This is actually M51. This is a galaxy way beyond this galaxy. What they did when the Hubble took this shot is they said, let's try to focus in on the center of this galaxy, M51, this Whirlpool Galaxy, located a shocking 30 million light years from home, and see if we can see the black holes that are there. And so they focused the Hubble on the center of M51. Let me show you the shot they got back. Now, I know what you're thinking. You're thinking, Rich, Jesus is not in M51. No, Jesus is not in M51. Can I tell you something? The heavens declare the glory of God. The firmament shows forth His handiwork. Yes, it's dust, and yes, it's gravity, and yes, it's light. If you doubt me, go look at it. It's on Hubble.gov. This is M74, another Whirlpool Galaxy, 32 million light years from home. Look at these stars, these clustered stars. Absolutely gorgeous. This is the Barred Spiral Galaxy, NGC 1672, a shocking 60 million light years from home. Another Barred Spiral Galaxy, NGC 1300, 70 million light years from home. NGC 7049, also known as the Crown of Thorns Galaxy. Is that beautiful? The heavens indeed do declare the glory of our sovereign God. 100 million light years from home. Polar Ring Galaxy, NGC 4650, a shocking 130 million light years from home. I come to this conclusion. The heavens indeed do declare the glory of God, and there is not a single language on this planet who has not heard His voice declaring how great and how magnificent and how awesome He really is. And all men will be left without excuse on that day. But let's get back to the study. I just want to take you on a little trip around. Some shots from Hubble. I thought you would enjoy that. Let me get caught back up here. So this is the evolutionary timeline we talked about last week. We'll continue to talk about this timeline. So it starts here, right? The Big Bang, 13.7 billion years ago. The first stars form almost immediately, which is rather shocking, but they need them to form then because already this thing is collapsing on itself, as you'll see tonight. Galaxies begin to form somewhere in the 11 to 8 million year point, but you'll see that's totally wrong now. Their theory, their ages. And supposedly our Milky Way formed at 9 to 7 billion years ago, with the Earth forming at 4.6 billion years ago. So this is what we'll always continue to come back to as their timeline. Why is the Big Bang unscientific? We talked about it last week just to sort of summarize. The idea that nothing exploded for no reason and created everything is absolutely foolish and indeed unscientific. And I would agree with R.C. Sproul. I think he said it best. If there was ever a time when indeed there was nothing, there will never be anything. And that's the bottom line. But equally, it goes beyond that. Inflation, which I talked about last week. So let me explain it real quick in a way that's easy to understand. Inflation was added to the Big Bang Theory when they were finally able to measure the cosmic background radiation. They had made predictions on what the CMB, the cosmic background radiation, would look like. And when they actually were able to measure it, it looked nothing like the Big Bang predicted it would look. So you're still thinking, well, I don't get it. What is it? It's the leftover heat from the Big Bang. It's the leftover radiant heat that's still there. In fact, if you took a coffee cup and set it on a table and it was hot, and you picked up that coffee cup, there would be remnant heat. That's what the CMB is supposed to represent. When they measured it, it was nothing like they expected. And so what they did is, rather than throw out the theory, they came up with the idea of inflation. That the universe expanded after this dot had exploded for no reason, it then rapidly expanded, exceeding the speed of light by a factor of hundreds, until it was billions of miles across, and then it slowed down again to the speed of light. Totally outside of physics, totally outside of science, totally unprovable. Particle physics has never seen the inflaton. Again, this is all added to the Big Bang Theory to make it match what we observe. The same is true with dark matter. We talked about that. Again, by the theory, 85% of our universe is made up of stuff that we cannot see, measure, detect, or in any way find. We've spent the last 20 years trying to find dark matter, which supposedly 85% of our universe is made up of, and we've not found one single particle of dark matter. The same is true of dark energy. Dark energy is needed to keep the universe picking up in speed of expansion. Again, because of this is not reality, this is all imposed because of the Big Bang Theory. We've never found dark energy, and it's unlikely we ever will. It's a completely made-up idea to keep the Big Bang Theory alive. And that's not even talking about magnetic monopoles. We talked about that last week. The curvature of space, which didn't match. The fact that the CMB was thought to show the direction of the Big Bang, and in fact, it's universal. There's no direction to it. And we've not even gotten to the scientific laws that the Big Bang violates. The bottom line, at this point, the Big Bang has, to be very kind, serious problems. The Big Bang is flawed, but for the next 40 minutes, I'm going to ask you to set that aside. And let's pretend, for the sake of our discussion tonight, that nothing exploded for no reason and produced massive amounts of hydrogen, helium, and small amounts of lithium. The question then becomes, can we get stars and planets from galaxies from that? So we'll just accept for the moment, we'll set that aside, that it couldn't have happened. We'll pretend it did. Can phase 2 happen? That becomes our question. This first video is from Spike Psaris. This is from DVD number 2 out of the series, What You Aren't Being Told About Astronomy.
If the Big Bang model were true, should we see stars in the sky today? The answer to this will probably surprise you, especially because there are frequent announcements about discoveries of star-forming regions in space, like this nebula. We're told that we see lots of places where stars are forming today. Evolutionists like to point to regions like this as support for their model, but that's a logical fallacy, a red herring. Whether or not stars are forming in the universe today, or whether they could form in the universe today, is not the question. The question is this: if the universe formed itself, as the Big Bang model says, without a creator being involved, would we see stars today? And the answer is no. Here's why. In the Big Bang model, stars are supposed to have formed from clouds of gas, as gravity squeezed the gas together. But there's a problem here. A cloud of gas in space will not collapse into stars on its own. It's true that gravity pulls the gas molecules together, but gravity is a relatively weak force, and it's much weaker than gas pressure, which forces the gas molecules apart. Here's an illustration I like to use. This is a can of compressed air. When I pull the trigger, it opens a passage from outside the can to inside the can. So what happens when the gas can travel freely? It comes out, because gas always disperses from areas of higher pressure into areas of lower pressure. When I give talks about this, I like to ask the audience, how much gas would you need inside the can to create such a strong gravitational force that when I pull the trigger, gas wouldn't come out of the can? Instead, all the air in the room would get sucked into the can, and we would all asphyxiate and die. People laugh because this idea is ridiculous, but that's the kind of concentration of gas you would need to form stars from a gas cloud in space. You can't maintain a cloud of gas at a higher pressure than its surroundings unless you keep it in a container of some kind. This can is a container, so the gas stays inside without dispersing. But there aren't any containers in space, so there's nothing that prevents gas clouds in space from dissipating. Not only that, there are other things that will prevent a gas cloud from collapsing into stars. As one evolutionist wrote, We know the cloud wants to collapse under its own weight to make one or more stars. But rotation, as well as turbulent motion within the cloud, work against that fate. So too does the ordinary gas pressure you learned about in high school chemistry class. Galactic magnetic fields also fight collapse. They penetrate the cloud and latch onto any free-roaming charged particles contained therein, restricting the ways in which the cloud will respond to its self-gravity. But you might be wondering something by now. If stars are made of gas, and if gas clouds in space will disperse, then how can stars exist? It's because they're much denser and much smaller than the gas clouds we're talking about. Gravity is stronger at higher densities and smaller distances. Therefore, if there's enough gas in a small enough volume, gravity is strong enough to overcome gas pressure. That's why stars are stable, even though they're made of gas. But interstellar gas clouds are too large and too diffuse for gravity to overcome gas pressure. So they won't collapse and form stars. They'll disperse instead. Evolutionists know this is true, but they need to have stars form out of gas clouds in order for their model to work.
So at this point, the question becomes, okay, gas clouds, stars, well, what theory do they have for the formation of stars? Well, they all involve the idea of gravitational collapse. They all need this dust cloud, this gas cloud to collapse, gravity to take over and to pull this thing together. And they have a few theories. The first one is gas cloud compression. The idea is here that when a large star dies and becomes a supernova, that supernova sends out a shock wave that compresses gas clouds and can create a star in theory. The second one is collision. The idea is here that a universe or a galaxy would collide with a dust cloud, with a gas cloud, and that collision would cause the birth of a new star. That's their second theory. And their third theory is a black hole. A black hole, they believe, jets out enough material and enough radio waves that it too can collapse these gas clouds, these gas and dust clouds, and actually start a star. Now, if you listen to all those explanations, you go, okay, I guess that makes some degree of sense. Well, here's the problem. Every one of those scenarios required stars to make stars. In every one of them, we were using pre-existing stars or dying stars to create new stars. That's not what we're asking. We're asking, how did the first stars form? That's what we're asking. That's the question we're trying to get at. And so again, we'll let Spike talk about it.
This is a huge problem for the secular model. The Big Bang can't make any stars until stars already exist. It's like the classic riddle of the chicken and the egg. You need chickens to make eggs, and you need eggs to make chickens. The Big Bang model has this problem on a much larger scale, a universal scale. It can't make stars until stars were already made. Add up all these problems, and you see why evolutionists say things like this. The origin of stars represents one of the most fundamental unsolved problems of contemporary astrophysics. There are so many uncertainties in this picture that at present we do not really have a theory of star formation. If stars did not exist, it would be easy to prove that this is what we expect. Most of us are persuaded that stars form out of more diffuse material, which must, therefore, condense, contract, accrete, etc. Nevertheless, nearly all observations of pre-main sequence and protostars are dominated by outflowing stuff. Literally hundreds of ideas on how stars were formed have been advanced in past decades. However, we are still far from any real solution. We're starting from a shaky foundation. We don't understand how a single star forms, yet we want to understand how 10 billion stars form. If none of us knew in advance that stars exist, frontline research would offer plenty of convincing reasons for why stars could never form. Remember this the next time you admire the night sky. All the stars you see, and billions more that you don't see, all defy the evolutionary model just by existing. Now, some people claim that what I just said isn't true. They'll say this problem has been solved because there were some announcements recently that claimed that it was. For example, here's a report about a computer simulation that supposedly showed how the very first star could form. And here's another. But here's what they aren't telling you. These simulations all require something called dark matter. And if you ask an evolutionist what dark matter is, they'll tell you they don't know. Many astronomers believe that there's a lot of stuff in the universe that we can't see. There's supposed to be a huge amount of it, 5 times as much as all the stars and galaxies and everything else that we do see in space. But if you ask where all this matter is, they'll tell you it's invisible. It emits no light. It emits no radio waves. It emits no X-rays or infrared radiation. It's unlike everything else we know, but it must exist, or else their models don't work. We'll talk more about dark matter in the next video in this series. For now, I just want to point out that in order to explain where the first stars came from, evolutionists have to invoke things that nobody has ever seen and that nobody has any idea what it is or how it works. As a cosmologist recently told the BBC, "We don't know what the dark matter is. We don't know what the first stars are. If we bring these two problems together, when we know more about one, then we can say something about the other." Well, that doesn't work. Being ignorant about two things at the same time doesn't teach you anything about either one. If we don't know what dark matter is, how it works, where it came from, whether or not it could even have been formed by the alleged Big Bang, how it behaves, whether or not it interacts with ordinary matter outside of gravity, or anything else, then how can we make it part of a scientific model? The only reason dark matter can supposedly rescue star formation for the evolutionists is because nobody knows what it is, or has any definitive evidence for how it might work. So evolutionists are putting it in their models and claiming it can do all sorts of wonderful things because nobody can prove that it can't do all these wonderful things. But that's not how science is supposed to work. And even then, scientists have realized that not even dark matter can rescue the Big Bang from all its problems. So evolutionists also believe in something called dark energy. Together, dark matter and dark energy must be about 96% of the universe, or the Big Bang model can't work. But neither dark matter nor dark energy has a solid basis in physics. As the director of the Canadian Institute for Theoretical Astrophysics said, "We know the total matter content of the universe. It's 4%. That's the stuff we recognize as matter. The rest is something we don't understand." There was an article in the New York Times that talked about this. It talked about how the Big Bang cosmology depends on dark matter and dark energy. The article asked, "What is dark energy anyway?" And then it said, "The difficulty in answering that question has led some cosmologists to ask an even deeper question. Does dark energy even exist? Or is it perhaps an inference too far?" Cosmologists have another saying they like to cite. You get to invoke the tooth fairy only once, meaning dark matter. But now we have to invoke the tooth fairy twice, meaning dark energy. So evolutionists make jokes about how their model doesn't work unless you invoke the tooth fairy. Meanwhile, the public schools are teaching our children that the Big Bang model is true. There's a serious problem here.
Now hold on. I thought we started this evening with that the Big Bang produced hydrogen, helium, possibly some lithium. And all of a sudden we learn that dark matter is thrown into the equation to even get initial star formation. Yet none of their theory has any idea of where dark matter comes from, or even when dark matter comes into this equation, or even what it is. You can't use dark matter to help create the first stars when you don't know what it is, you have no idea when it was created, and it's not even part of the theory. It's a bolt-on. And that's really where the theory is right now, even on initial star creation. I'd ask the question, is this really science, or is this something else? One more video from Spike.
According to the Big Bang, there shouldn't be 100 billion or so galaxies in the universe. And even if stars could somehow be formed, getting galaxies to form from the Big Bang would still be a tremendous problem. Evolutionary astronomers even admit this is true. It has always been difficult for astronomers to explain why stars are clumped into galaxies instead of being spread out more uniformly in space. There shouldn't be galaxies out there at all, and even if there are galaxies, they shouldn't be grouped together the way they are. The problem of explaining the existence of galaxies has proved to be one of the thorniest in cosmology. By all rights, they just shouldn't be there, yet there they sit. It's hard to convey the depth of frustration that this simple fact induces among scientists. The formation of galaxies and larger scale structure remains TMI-UPIMA, the most important unsolved problem in modern astrophysics. Nearly a century after the true nature of galaxies was established, their origin and evolution remain great unsolved problems of modern astrophysics. While we're talking about galaxies, there's an additional problem that's been getting worse lately. As technology improves, we're able to look farther out into the universe than ever before. The Big Bang model makes predictions about what we should be seeing out there, but the galaxies we're seeing aren't matching the Big Bang's predictions. We can now see galaxies that are so far away they can only be seen by using the world's most powerful telescopes. Evolutionists calculate that these galaxies are so far away that their light would have taken billions of years to get here. Therefore, they figure that when we see these distant galaxies, we're seeing them as they were billions of years ago. Now, this isn't necessarily true. There are other ways to interpret these observations. We'll talk more about this in a later volume of this video series. For now, just remember that this is how evolutionary astronomers interpret these galaxies, and that this is not the only possible interpretation. So evolutionists believe that when we see these faraway galaxies, we're seeing them as they were billions of years ago. In fact, evolutionists believe that as we look farther out, we'll see galaxies as they used to be, farther back in time. So as we look farther and farther out, we would see galaxies as they used to be, closer and closer to the Big Bang. Well, the Big Bang model makes predictions about what these things should look like. It turns out that some of these objects do look different in some interesting ways, but they aren't matching the Big Bang's predictions. Evolutionist astronomers had calculated that galaxies formed 8 to 11 billion years ago. That's because according to the secular model, it takes 3 to 6 billion years for galaxies to form. So, as we started to look farther out into the universe, evolutionists expected to start finding immature galaxies that were still forming. But that's not what has happened. As we've looked farther and farther out, we're discovering mature galaxies at farther and farther distances. This has been called the early mature galaxies problem. We're finding mature galaxies where the Big Bang model says there shouldn't be any. For example, in 2004, astronomers announced the discovery of 300 mature galaxies that are so far distant that evolutionists believe we're seeing them as they were just 3 to 6 billion years after the Big Bang. The problem is that the Big Bang model predicted that only a handful of galaxies could have formed in such a short time. One secular astronomer said, "We expected to find basically zero massive galaxies beyond about 9 billion years ago, because theoretical models predict that massive galaxies form last. Instead, we found highly developed galaxies that just shouldn't have been there, but are." Another astronomer commented, "It's not quite time for theorists to panic, but we're getting there." The mature galaxy problem got worse when astronomers studied an enormous galaxy cluster that was farther away than any other cluster seen before. This is a huge structure, with the equivalent of several thousand galaxies like our own Milky Way. According to the Big Bang interpretation, it's not quite 4 billion years old, but it contains reddish and elliptical galaxies that, according to the secular interpretation, are supposed to be ancient. As one report commented, the discovery of such a complex and mature structure so early in the history of the universe is highly surprising. Indeed, until recently, it would even have been deemed impossible. Another group announced they had observed a group of galaxies that existed only 2.5 billion years after the Big Bang. But contrary to secular expectations, they were not only massive, but also very old. The astronomer said, "We are really amazed. These are the earliest, oldest galaxies found to date. Their existence was not predicted by theory. We're detecting galaxies we never expected to find, having a wide range of properties we never expected to see." A separate discovery showed 4 massive galaxies that, according to the Big Bang, had already formed when the universe was just 2 billion years old. The preeminent scientific journal, Nature, wrote about the discoveries and admitted, "It is clear that even the best models can't fully explain the evolution of galaxies." Then the mature galaxy problem got worse again, with the discovery of 5 large galaxies that the Big Bang says shouldn't be there. According to the secular interpretation, we're seeing them as they were just 1.7 billion years after the Big Bang. The report in Science talked about evolutionary models for star formation and complained, "But this process was supposed to take billions of years." It quoted one of the astrophysicists on the team who said, "We have no idea why these galaxies grew so large so soon." Not only that, the Spitzer Space Telescope team has found galaxies which supposedly had already formed just 1 billion years after the Big Bang. Then in 2007, astronomers announced the discovery of galaxies which had already formed just 500 million years after the Big Bang, just 1/2 of 1 billion. The Big Bang model says stars were barely beginning to form this early, yet here are hundreds of billions of them already collected into galaxies. And the discoveries have continued. In 2008, one report said, "The presence of such fully evolved galaxies so early in the life of the cosmos is hard to explain and has been a major puzzle to astronomers studying how galaxies form and evolve." In 2009, Nature reported more discoveries and said this, "The findings could overturn existing models for the formation and evolution of galaxies." That was the reason for the surprise, that it disagrees so radically with what the predictions told us we should be seeing. The farther out we look, the more we see that the universe does not match the Big Bang model.
So this forces a question. How long do we cling to a theory that's completely fallen apart? The Big Bang theory itself has created all these problems. We're now looking back to the point where, according to the theory, we should barely be seeing stars form, and we're already seeing complete, massive, intact galaxies. However you look at this, the theory has completely fallen apart. We are finding complete galaxies where we should be finding empty space. An honest appraisal of the theory is, in totality, it is no longer tenable. As mentioned earlier, according to the theory, the Big Bang only produced hydrogen, helium, and possibly small amounts of lithium. Ooh, a periodic table. Oh, yeah, Sandy smiled. The rest were, whoa. So we said hydrogen, helium, and lithium. Well, this would force a question for the most thinking people. Rich, where did all the other elements on the periodic table come from? That's a fantastic question. Well, the current theory is, with some support, that in stars you can fuse up to about iron. You know what the theory is for the elements beyond iron? There isn't one. They used to think they could be created in a supernova. They've now discarded that theory. They do not have a theory for everything from copper all the way to uranium. They have no theory for the formation of all those heavy elements. This is Discover Magazine, 2002. It has the 11 greatest unanswered questions of physics. It says this: resolution of these profound questions could unlock the secrets of existence, and deliver a new age of science within several decades. These are big questions. These are important questions. These are those questions we really want to know. Now, based on the last 2 weeks, what do you think the number one question is? No? Somebody said it. What is dark matter? That's the number one question in 2002. You ready for the number one question in 2018? What is dark matter? What do you think question number 2 is? You guys are on it. What is dark energy? Guess what the number 2 question in 2018 remains? What is dark energy? Question 3, I'll show it to you. How were the heavy elements from uranium, or from iron to uranium, made? Guess what the still ongoing question, we have no idea. How are all those heavy elements beyond iron made? We have no idea. I have an idea. The evolutionary theory has no idea. The Big Bang theory has no idea. But here's what's shocking. Let me show you number 11 of the 11 most important questions. How did the universe begin? You know, our children are not being taught that scientists think this. Our children are being taught that this is how it began. Meanwhile, the scientists have no idea, and they're honest about it. It's question number 11. We have no idea how it began. The theory of evolution, cosmic and stellar, planetary, cannot provide a legitimate physics-based answer to the questions about where this universe, or the stars, or the planets, or the galaxies in it came from. Now, interestingly enough, the Bible, which is not a science textbook, right, but does talk about stars. In fact, the first one, Genesis 1:14 through 16, it's the 4th day. God said, "Let there be lights in the firmament of heavens to divide the day from the night, and let them be for signs and for seasons and for days and for years, and let them be for lights in the firmament of the heavens to give light on the earth," and it was so. And God made 2 great lights, the greater light to rule the day, the lesser light to rule the night. And almost as an afterthought, Moses records, he made the stars also. Just kind of oh yeah, just so you know, Pastor. He made those too. Now I have a question for you. Any idea how many stars there are? A lot? So when I became interested in this a few years back, the number was 70 sextillion. Now, if you're trying to get your head around how big of a number that is, it's larger than our national debt, which is pretty shocking already. It's a 7 with 22 zeros. Well, guess what? It's been a few years since I was dabbling in this. The estimate has changed. It's now 100 octillion. That's a 1 with 29 zeros behind it. Now, if you're like me, I'm having a problem, Pastor, getting my head around 100 octillion. Well, let me help you get your head around it. Let's start out with 100 octillion stars and 14 billion years. And let's just say, now, obviously, they only say it's been here for 13.7 or 13.8, but let's say 14 to work with round numbers. How many stars would we need to create every second to have the current stars we have? Well, obviously, we need to divide by years, and divide by days, and divide by hours, and divide by minutes, and divide by seconds to learn that we would be creating 226 billion stars every second for the last 14 billion years to have the number that is now currently estimated. But there's a larger and more profound problem. The average star life is about 10 billion years. So guess what we should be seeing in the cosmos around us? Billions of stars dying. They should be dying all over the place. It would be hundreds of billions a second. I have a theory as to why we don't see those stars dying at that rate. Back to the Bible. This is Jeremiah. Now the context, what Jeremiah is talking about is that God is going to grow His kingdom. God is going to expand His tent. And the host of heaven cannot be, as the host of heaven cannot be numbered, nor the sands of the sea measured, so I will multiply the descendants of David, my servant, and the Levites who minister to me. That's the promise of the gospel. But look what the prophet Jeremiah said in 600 BC. As the host of heaven cannot be numbered, just like the sand of the seas. The sand on the shore cannot be numbered. The grains cannot be counted. When Jeremiah wrote this, no astronomer would have agreed with that. In fact, they would have said, oh, in fact, the stars can be numbered. It's around 1,000. In fact, the Greeks held to that idea. The telescope wasn't invented until the 1600s. The Bible was declaring something that no scientist, no astronomer would have agreed with, period, until the 1600s. And the Bible the whole time, almost 2,000 years in advance, was declaring the stars could not be numbered. This is Paul writing to the church in Corinth. Now again, the Bible is not a science book, but when it makes off-the-cuff comments, it turns out they're scientifically accurate. So the context here, as Paul writes to the church in Corinth, is the resurrection. The idea is just as when we do with a seed and a plant, the seed is much different than the plant. The body that goes in the ground would be much different than the body that comes out of the ground. Paul says this, there's one glory of the sun, another glory of the moon, another glory of the stars. No one would disagree. The sun, because it's close, it's a very unique glory. The moon that's reflecting the light of the sun, a different glory. And the stars that are out there in the cosmos, a different glory. But look at what Paul says next. For one star differs from another star in glory. Now keep in mind, this was written somewhere in 53 to 55 AD. No one would have agreed that all the stars differ in glory in the cosmos. Nobody. But guess what we know today? Now this is the biggest one I could get and still have some kind of visual representation of our sun. Our sun is the dot that you may not be able to see right there. That's our sun in this visual representation. And Antares is not the largest star. See why Scuddy is. I would say the stars differ in glory, but it's not just size. This is an illumination and a heat chart. Our sun is about right here. This is our sun right here. It ain't about right there. But the stars differ drastically, not only in size, they differ drastically in composition, they differ drastically in illumination, they differ drastically in color. Indeed, Paul's unscientific, off-the-cuff statement that the stars differ from one another in glory turns out to be scientifically completely accurate well before anyone imagined this idea. So I would ask you, is the Big Bang scientific? Or does it turn out a Bible that's not even scientific? Because it's inspired by God, when it talks about scientific topics, proves to be extremely scientific. We'll skip this. Well, we got time, Pastor? Or? It's 4 minutes. We'll watch this and then I'll wrap it up with a little tour around our solar system.
The dominant evolutionary model today is called the solar nebula model. According to this model, our solar system formed from a swirling cloud of gas and dust about 4.5 to 4.6 billion years ago. The evolutionary story goes something like this. In the beginning, there was gas. About 4.6 billion years ago, an enormous cloud of gas collapsed and started to swirl. Most of the gas went into the middle and became our sun. The rest of it swirled around the new sun and started to condense into grains of dust. As the grains of dust orbited the sun, they started to stick together and became clumps of dust. Then the clumps stuck together to become little rocks. The little rocks stuck together to become big rocks. After enough time had passed, the gas had turned into huge asteroids. These asteroids stuck together to become the planets we see today. Astronomers have a special name for these asteroids. They're called planetesimals, which means little planets. Since you probably haven't heard this word before, I'm going to call them asteroids instead. It means basically the same thing anyway. For example, most secular astronomers believe that the asteroids we see in our solar system today are leftover planetesimals that never quite got it together to form planets. Evolutionists are confident that their model is correct. After all, it explains why all the planets orbit the sun in the same direction. It also explains why the solar system is flat today, with all the planets lining up in a disk shape as they orbit the sun. Plus, it explains why the inner planets are rocky, and the outer planets are made of gas and ice. Supposedly, the heavier rocky materials were able to condense close to the sun, while the lighter materials were more volatile and could only condense further away from the sun. Sounds good, doesn't it? The problem is that it doesn't work. It turns out that you can't build planets like the evolutionists say. You can build clumps of dust, certainly. We know that dust particles stick together. Just look under your furniture and see the dust bunnies there for proof. Well, experiments in space have shown that dust bunnies will form in a vacuum, too. The problem is that once you have big clumps of dust, and maybe even some small pebbles, they don't grow together anymore. They start impacting each other too fast to stick together. Instead, they start breaking each other up in the collisions. Gravity isn't strong enough to overcome this until after the rocks have formed into small asteroids. So, despite the fancy computer animations you see on science videos, there's no way to get from dust clumps to planets. Evolutionary astronomers know this is true. That's why you see quotes like this one in the astronomy textbooks. Once these planetesimals have been formed, further growth of planets may occur through the gravitational accretion into large bodies. But just how that takes place is not understood. And in the scientific journals, we see comments like this. The formation of planetesimals, the kilometer-sized planetary precursors, is still a puzzling process. How the first stage of this process, primary accretion, works is a fundamental unsolved problem of planetary science. So before we even discuss any planets or moons, the evolutionary theory is breaking down already. It can't produce the asteroids it needs to build the planets.
So I'd like to take us real quick on just a little trip through our solar system, because here's the reality. Every planet in our solar system defies the evolutionary process in one way or another. This is Mercury. Far too dense. In fact, they now believe 40% of the planet is iron. There's no solar nebula theory model that creates Mercury. And there's another problem. It has a magnetic field. It should have died out and been cold, no magnetic field. Even if it had one at some time, it would be long gone. And yet there it stands, far too dense, with a magnetic field. Decaying, but a magnetic field. Venus, very young surface. In fact, very few pit marks from asteroid impact. What the evolutionists now believe is, well, it must have been completely resurfaced a couple of 100 million years ago to give it that young look. This is Earth. Two issues, well, a lot of issues going on here. I'll just touch on two of them. First, a very strong magnetic field that's rapidly decaying. If the planet were 4.6 billion years ago, either the magnetic field would have been so strong in the past that it would pull the iron out of your blood, that would have been option number one, or it doesn't fit the evolutionary model at all. We have the half-life, it's 1,400 years. Equally, the planet has far too much water for something that started out as a molten ball. If you flatten the planet out, 1.4 miles of water on this planet would cover the planet. The evolutionists say they got here from asteroids. You've got to be kidding. How many asteroids are we talking? Mars has 2 moons, Phobos and Deimos. Both have very circular, tight orbits. Phobos orbits the planet every 7 hours and 39 minutes. Deimos a little over 30 hours. The evolutionary model cannot explain how Mars has those 2 moons. Jupiter, far too large, and the chemical composition is impossible at the range that Jupiter's at. No model creates that massive planet at that location. The same is true of Saturn, far too large for its current location in our solar system. The solar nebula theory will not produce this planet. Equally, the rings, they're about 30 feet thick. If they were millions of years old, they would have been completely destroyed by now. And here they stand as a testimony that rejects the evolutionary thought. Uranus is incredible. So it's actually, every planet in our solar system is rotating on its axis like this around the sun. Except Uranus. It's rotating like this around the sun. Its axis is tilted completely over and it's rolling like a ball around the sun. Guess what? The solar nebula theory does not have an explanation, a legitimate explanation, for how Uranus is tilted completely on its side and rolling like a ball around the sun. And you ready for this? It too has a magnetic field. Again, should have been burned out a long time ago. Neptune, radiating more energy than it receives from the sun. That's absolutely impossible unless the evolutionary theory is completely wrong on the age of Neptune. And guess what? It has a magnetic field as well that should have been long gone if the evolutionary process were true. In summation for tonight, to keep the Big Bang working, we've hobbled together dark energy, dark matter, and inflation. All of those not based in physics, not based in science. We have no working theory unless we add in dark matter, which we don't even know when that came into the equation, on how the first stars formed, much less 100 octillion of them. Actual experiments prove that you will not build planets the way the evolutionary model has them being built, out of small scraps of dust and rock. All the studies show that once they get about a meter size, 3.5 foot in size, they start breaking each other up. And then finally, every planet in our solar system, in one way or another, becomes problematic for the solar nebula theory, problematic for the evolutionary theory, problematic for the Big Bang. I would ask, is this really science? Is this facts learned through experiments and observations, or is this something else? I'll end here tonight. The heavens indeed do declare the glory of God.